We are going to take a look at Lesson 3.2 on page 297 of your textbook. This lesson is titled A Snow Job. It deals with writing, interpreting, and evaluating algebraic expressions. Towards the bottom of the page, it says Section 3.2 Class. If you were running a business like the one that sells snow cones, you'd probably have a lot of data related to your costs and the amount of money you can make. And if you had also completed the first 2 units of this course, you'd know a lot about organizing and working with data. So let's put some of this stuff together about a snow cone stand. First, we need to understand a little bit of terminology from business and economics. The amount of money that a business needs to spend for their operation is known as their costs. The amount of money that the customers pay for the goods or services is called revenue. The difference between these two numbers, the revenue minus the cost, is known as the profit. Number 1 says when a company is making money, which is the goal, the profit will be positive. What is the relationship between the revenue and the costs if the profit is positive? Well, if the profit is positive, then the amount of money I'm bringing in, the revenue, has to be more than the amount of money I'm spending than the cost. So if I am making a profit, my revenue has to be more than my cost. Turning the page to page 298, we see a spreadsheet. This spreadsheet describes the costs associated with a snow cone business, as well as the revenue and profit we can expect to earn. Just to get familiar with it, read through some of the columns. A is the number of snow cones sold. Column B is the number of cups needed. Column C is the cost of those cups. Column D is the amount of syrup needed. Column E is the cost of that syrup. Column F is the ounces of ice we need. Column G is the cost of ice. Column H is the combined cost of cups, syrup, and ice. Column I is a fixed cost. You notice it's the same all the way down. It's just some fee we have to pay. J is the total cost, so it's actually column H plus column I. K is the revenue, so that's how much money I'm earning when I sell snow cones. And then L is the profit. It is my column K minus my column J. So using this chart, I'm going to try not to scroll up too far here. If 300 snow cones are sold, how many ounces of syrup are needed? Well, 300 snow cones is here in row 5. How many ounces of syrup do I need? Looks like I need 600 ounces. What if we sell 500 snow cones? How many ounces of syrup do we need? Well, we need 1,000 ounces of syrup. Number 3 says a formula was typed into cell D5 to obtain the result you used to answer question 6. What formula would give the correct result? Well, I would have had to type in equals 2 times the number given in cell A5. So for example, 600 was equal to 2 times 300. 1,000 is also equal to 2 times 500. So we're working our way towards a formula or an expression. Number 4 says write a verbal description of the relationship between the number of snow cones sold and the number of ounces of syrup that will be needed. So the ounces of syrup is twice or 2 times the number of snow cones. Which is what we showed in problem number 3 as well. Problem number 5 then says complete the following sentence. If X represents the number of snow cones, what represents the amount of syrup used? Well, if X is the number of snow cones, then 2X, or 2 times X, is going to represent the amount of syrup I need. At the top of page 299, we get to number 6. It says, all right, let's write the same thing as a formula. Using the letter S to represent the amount of syrup used, write a formula that describes the ounces of syrup needed in terms of the number of snow cone. We know that the ounces of syrup needed is 2 times the number of snow cones. Seven goes back to this idea of dependent and independent that we've looked at before. 7 asks, does the number of snow cones sold depend on the amount of syrup, or does the amount of syrup depend on the number of snow cones? We're going to say that the amount of syrup depends on the number of snow cones. So the amount of syrup is going to depend on how many snow cones I sell. Question number 8 says, in your formula from question 6, which is the independent variable and which is the dependent variable? X is my independent variable. That's the number of snow cones sold. And S is the dependent variable, the amount of syrup. So I put in how many snow cones I'm going to sell, and out will come how many ounces of syrup I need. 9 again explores something we've done previously. It says, is the relationship between the amount of syrup used and the number of snow cones sold linear, exponential, or neither? It appears constant. It's always 2 times the number of snow cones, so that's linear. And we'll say it's linear because it's always constant. It's always 2 times the number of snow cones sold. Ten takes us down a different path. It says go back and look at that spreadsheet. If X is the number of snow cones sold, which quantity is represented by 5 times X? So let's go back and look at our chart here. I'll go back 2 pages. So if I sell 100 snow cones, what would 5 times 100 be? Well, it would be 500. So I'm going to look at 100 and go all the way across until I find 500. And I found it. So it looks like 5 times X is going to be the amount of ice. Let's see if that works somewhere else too. If I sell 200 snow cones, 5 times 200 is 1,000. Yep, it's the amount of ice. So our answer to number 10 is the ounces of ice. So ounces of ice. Turning the page to page 300, it says if we sell 70 snow cones, what is 5 times 70? So they're asking me to calculate 5 times 70. I can put that into a calculator. It should be 350. They asked me to write a sentence or two explaining what that means. It means if I sell 70 snow cones, I need 350 ounces of ice. Question number 12 says if you were to graph the data in columns A and J from the spreadsheet with the number of snow cones on the horizontal axis and the total cost on the y-axis, would it be a straight line? Our answer is yes, because again it's a constant rate of change. "13 says now do it. Graph the points on the chart. So let's go back to our snow cone business. We're graphing the total cost and the snow cones. So when I sold 0 snow cones, my total cost was $245, so pretty close to here. I am terrible at drawing lines. 100 snow cones, my total cost was $257. So we're looking at a very, very flat line here. When I sold 200 snow cones, it was $269. 300 snow cones was $281. It is a straight line. I'm just not drawing it great. It's very flat. 400 snow cones was $300. And 500 snow cones. Oops, I just did that last one wrong. Let's erase that real quickly. Let's fix that one. I read the wrong column. 400 snow cones, the total cost was $293, so we're getting pretty close to 300. And 500 snow cones cost just over 300. So a very, very flat line. They asked me for the y-intercept. That's this point right here where it crosses the y-axis. That's the point 0, 245. Number 14 wants to ask us the unit rate that describes the combined cost of all the supplies per snow cone sold. So let's look back at our table. I know the combined cost for 100 was $12. So if I take $12 divided by 100 snow cones, that's going to tell me how much it costs per snow cone. So go ahead and divide that out in your calculator. You should find out that it costs 12 cents per snow cone. Number 15 says pick 2 points from our graph or the table and find the slope connecting them. So let's use the 0, 245. Smaller the numbers I can use, the better usually. And then 100 snow cones cost me, I turn back and look at my chart, $257. Remember, we've talked about how to find slope. To find the slope, I'm going to subtract the y values. So I'm going to take 257 minus 245. That's going to give me 12. In the same order then, subtract your x values. 100 minus 0. And then divide that out. Take 12 divided by 100, and you should see a number you recognize. You should get the 0.12 again. So whichever way we do it, we get that it costs 12 cents per snow cone. Turning to page 301, they're going to have us write several expressions for actually 16, 17, and 18. are going to have us write expressions for each item in the cost. Cups cost a penny each. So cups are going to cost 0.01 times the number of snow cones I sell. Syrup is going to be very similar. Syrup is going to be 0.04 times the number of snow cones sold. If 7 cents is spent on ice, then my expression is going to be 0.07x. 19 then does something really cool. It says take those three expressions and add them up. So the 0.01x plus 0.04x plus 0.07x. Since they're all x, I'm allowed to combine those because they're like terms. 0.01 plus 0.04 plus 0.07 is 0.12. That number keeps coming up and coming up and coming up. So the last thing we want to do is number 20. It says the total cost of selling snow cones is the sum of the variable cost, which we just found, that 0.12x, and the fixed cost, which they gave us in the problem, which was $245. So the cost per snow cone is going to be that $245 that I'm paying regardless of how many I sell, plus 0.12x. In the group work, you'll explore more with the cost and revenue and profit equations.